This is a modern waste gasification plant, a fully automated facility that transforms mixed municipal waste into clean, usable energy. Here, instead of burying trash in landfills, advanced gasification technology converts waste into syngas. Waste enters the site through a fully monitored logistics system, including a digital weighbridge that tracks every ton of material processed. Inside the enclosed tipping hall, trucks discharge mixed household waste into a deep reception pit, designed to control dust and odors. A fully automated overhead crane continuously transfers waste from the pit to the feed conveyors, optimizing the load for stable gasifier operation. The main feed conveyor is equipped with variable speed drives and level sensors, keeping the flow of waste constant and precisely controlled. An eddy current separator recovers non-ferrous metals like aluminum, maximizing resource recovery and minimizing residual waste. A powerful overhead magnetic separator extracts ferrous metals such as steel cans and iron parts, sending them to a separate recycling stream. In the primary sorting area, bulky or unsuitable objects are removed manually and by robotic arms, protecting the downstream equipment.
Advanced optical sensors use near-infrared technology and AI to identify different plastics and paper, redirecting valuable recyclables with high-speed air jets.
A twin-shaft industrial shredder reduces the remaining waste to a uniform size, improving heat transfer and reaction efficiency inside the gasifier.
A lock hopper system carefully introduces waste into the reactor without allowing air to enter, preserving the oxygen.
From here, shredded feedstock travels through enclosed conveyors to prevent dust emissions, moving directly toward.
The gasifier itself is a high-temperature, refractory-lined reactor designed to convert solid waste into a combustible synthesis gas.
Inside the reactor, waste passes through several zones: drying, pyrolysis, controlled oxidation.
Steam and a carefully limited amount of air or oxygen are injected through nozzles, driving endothermic gasification reactions instead of full combustion. Operating temperatures often exceed 800 degrees Celsius. Thermocouples and infrared sensors continuously monitor the thermal profile inside the bed.
The product of this process is raw syngas, a mixture of carbon monoxide, hydrogen, methane, carbon dioxide.
The hot gas first passes through a cyclone separator, where centrifugal forces remove larger ash particles and char, dropping them into a sealed ash bin. A waste heat boiler recovers thermal energy from the hot syngas, generating high-pressure steam that can be used for power generation or process heating. Fine particles are captured by a multi-chamber baghouse filter, where high-temperature resistant filter bags remove dust down to a few milligrams per cubic meter.
An integrated wet scrubber then washes the beams, neutralizing acid gases like sulfur peroxide.
For high-quality syngas, a catalytic reactor is used to crack heavy tars and hydrocarbons into lighter gases, preventing fouling in downstream equipment.
Online gas analyzers continuously measure the composition of the clean syngas, feeding real-time data back to the plant's control system.
A distributed control system, or DCS, manages the entire process through a SCADA interface.
Operators fine-tune set points for temperature, pressure, and steam injection, while PID control loops automatically correct deviations in real time.
A syngas buffer vessel stabilizes pressure, ensuring a smooth and continuous gas supply to downstream engines or turbines.
One common configuration uses gas engines specifically adapted for low-calorific syngas, converting chemical energy directly into electrical power. The engines deliver continuous electrical power to the grid, with dedicated cooling and lubrication systems protecting critical components.
Generated power passes through switchgear and transformers, where it is conditioned, protected, and synchronized before entering the public grid.
In larger installations, syngas can drive gas turbines or combined cycle systems, boosting overall electrical efficiency. Recovered heat is used for district heating and industrial processes, creating a combined heat and power system with minimal energy waste.
Inorganic residues, such as ash and slag, are discharged through sealed screws or slag taps,
where the resulting vitrified slag is chemically stable and non-leaching, making it suitable as an aggregate in construction applications.
Ash is stored in sealed silos equipped with dust filters, ensuring safe handling and preventing fine particulate emissions.
Exhaust gases are continuously monitored for particulates, nitrox, sulfur compounds, and carbon monoxide.
The plant logs all emission data, demonstrating that pollutant levels remain far below regulatory limits throughout operation.
The reception hall is kept under negative pressure, with extracted air treated before release, minimizing odors and
Gas detectors, emergency shutoff systems, and fire suppression lines provide multiple layers of safety for both personnel and equipment.
Trained operators follow strict safety protocols and use appropriate protective equipment whenever interacting with process areas.
Artificial intelligence analyzes real-time data, predicting maintenance needs and continuously optimizing the plant's performance and fuel conversion efficiency. A digital twin of the facility allows engineers to simulate different operating scenarios, improving reliability and training new staff.
Regions. With high availability and stable throughput, the plant processes thousands of tons of waste per day, ensuring
Compared to conventional incineration, gasification offers improved efficiency, better byproduct quality.
By dramatically reducing the volume of waste sent to landfill, gasification helps conserve land and minimize long-term environmental risks.
When integrated with recycling and heat recovery, waste gasification can significantly lower the overall carbon.
The plant operates as a distributed energy hub, providing local electricity and heat that support the surrounding community and industry.
Every night, thousands of homes and businesses are powered in part by energy recovered from what would.
Multiple facilities can be monitored from a central control center, allowing experts to oversee performance across an entire regional network of plants. Educational tours help citizens understand how advanced waste treatment works, building trust and awareness in modern environmental solutions.
Regular preventive maintenance and condition monitoring extend the lifetime of critical equipment, from valves and pumps to rotating machinery. A well-organized spare parts strategy ensures rapid replacement of components, minimizing downtime and guaranteeing continuous service.
The modular design of the plant allows new gasifier trains to be added as waste volumes grow or as new energy markets emerge. Long-term data logging proves the plant's stable performance, documenting how it safely handles waste over many years of operation.
In advanced configurations, high-purity hydrogen can be separated from syngas, paving the way for low-carbon hydrogen applications. The facility adheres to international standards for quality and environmental management, supported by regular independent audits and certifications. Behind the automation stands a highly skilled team of operators and engineers, trained to manage complex, high-temperature chemical processes.
Dedicated training simulators prepare staff for both normal operations and emergency situations, further strengthening plant safety.
Drones and remote sensors are used to inspect hard-to-reach areas, checking for structural integrity without exposing workers to unnecessary risks.
From the arrival of mixed waste to the final production of clean syngas, electricity, and construction materials, the
core idea is simple but powerful. Treat waste not as a burden, but as a potential resource.
A surrounding greenbelt helps filter dust, reduce noise, and visually integrate the plant into the landscape.
Reliable, modern waste treatment is a hidden backbone of urban life, helping cities remain clean, healthy, and livable. Running day and night, the gasification plant quietly turns everyday trash into valuable energy with minimal visible impact. Networks of such facilities can serve entire regions, replacing outdated dumps and uncontrolled burning with clean, controlled technology.
Built to industrial standards, each reactor is engineered for continuous operation under extreme temperatures and demanding conditions.
Every section of the facility, from waste reception to energy generation, is part of a single, integrated system.
This is modern gasification, turning the challenge of waste into an opportunity for clean, reliable energy.